Hi, well, I want to talk a little bit today about some extra work I did on the Zoom at the weekend. This is parsing the ZD2 files. And we'll go over that in a minute, what a ZD2 is. But based on some work Manjul done and my own investigations, what I found is that you can get the bitmap out. I may have said this in an earlier video. Um, and I worked out the TXJ1 must be the Japanese, the E is the English. And so I had something here which dumped out, and I found out in the on-off data, the max value and the cur, as I'm calling it. I really should call it the default value for an FX parameter is stored in there. And then when I got to this area down here, the parameter start, I found if I printed it out, I got like a JSON encoding. Now, I wasn't very good at pulling JSON into C and messing with it, but I decided to steal or borrow Mundrill's code rather, and I've made my own version here, Zoom Shooking, because I don't want to check it back in at the minute because I don't think this is up to his quality of code. But I change his vehicle to use a get file, and here what I do is I use a ZD2 parse to parse in the file name that's being passed down into it. And as long as it's more than 88 bytes, the magic DeLorean, then I get the file size and I very thunderingly hack out the 88 offset hex plus file size to a file, and that's the BMP. Then what I do is when I do this one, data, yeah, this is writing out the data. So data is what stores the ZD2. That's the file download. So that's the data from the pedal. This bin config is the parse that he does with the construct. And then what I do is I find the on-off starts and I work out. So I say 0 to 10 because the first on-off is the actual on-off of the parameter itself of the effect. The next one is the name. So 2 onwards is the parameter 0 if you want to use that phrase. Yeah, I find the text English start and I find where the parameters start. Then I take a subset of that and I look for where parameters is. I then look for a square bracket in this subset of the subset, and then I walk it, and until I find a square bracket end, then I basically print the chart of the binary data out, and this is effectively a concatenated string of the JSON. Then I can use the Python JSON command to turn that into a JSON payload, and I can inject in. So I go from 0 to the len of x. So this is the number of, this is an array of the parameters. So I go for the parameter and say, hey, have you got a corresponding max? And it's j plus 2, as we said, because 0 is the on-off, 1 is the fx, so 2 is the beginning of parameter 1. And so now I inject that into the JSON, or in fact, in this case, it's a Python object. And then I create a JSON object, which I say fx has got the name of the bin called name, the description that I created, the version from Munjwell, the ID, which is the bottom bottom short from it, and then the group ID. And then I open a file, I add in parameters of X, and I dump it. So that's what I'm doing. So let's actually look at that on the screen here. So I have this little command here that I run. So it's going to say zoom Z2 shooking because it's my version of it, but the first bit would work the same with Munjwell's code. So let me just edit copy that and let's throw that into there. Edit paste. Okay, so we get rid of the ZD2s, the JSONs, the BMPs. Then we run the Python 3, and this one is going to read. This is so it normally with Munjwell's code it would be without the shooking. So we just basically use his command as is to get the file table list, and I'm going to put it into my B14 because this is a B14X. Okay, so we middle button that or right hand button that in, and you see it's just put into PC mode, and it's that quick. It's got it. So what we have here is this my B1XFour, and it's a binary file. But if we now do a strings on that, you can see we have the ZD2 file and the version it's on. So, okay. Now what we can do, we can say for file in strings that grep for ZD2, run the command, and this is my extension, -g file. There might be a better way of doing this. I just found that that's the way I do it. So let's copy that in. Let's paste that in. Edit, paste. And now you see that the thing is going bump PC mode, off PC mode. And can you see on the screen we're pulling out the JSON every so often, okay? So that's the parameter. And what I've done is also modified Module's code for my own benefit to pump out a whole load of what it's up to for comparison with my C code, because I was using this C and also Lua for use on controller, because as far as I know, there's no easy way of using Python inside of the other code. So that's what I've been up to. So let's just let that run, and I'll put this on pause. If I can put it on pause, I'll do that. Okay, so it's gone through and it's got the list of stuff. It took about 4 minutes or so. So now we can paste the next commands in, and this will find us the list of the ZD2 files that have been pulled from the pedal, the JSON that we derived, and the BMP files with bitmaps. And actually, just for the good measure, if we now go into the Pi software and then we go into the Zoom Z2, then what we should see is a whole load of little BMP files. Yeah. So if we now make a directory and we move all that stuff there, let's do that, edit copy, and we paste that in somewhere. Oh, right and click, isn't it? Hang on. Right and click, edit, paste. The only thing I don't like about Linux, it makes this more complicated. Then all of these things are moved to there. So now what we can do is we can take the B1X out, B1XFour out, and we can pick up the G1XFour that we have down here. Okay, so what I just did then off camera was I did the same thing where I basically this time did it for G1XFour. It's just the name of a file, yeah. So I pull out the catalog with modification of, well, this is Munjul's code effectively. Then I look in that file for the ZD2s and I use my modification to pull out the individual ZD2s. There might be a way of doing it in code, I don't know. Then I remove the ZD2s, the JSONs, the BMPs. I look for the contents, I put them into a file, and that shows me that I haven't missed any. Then basically I make a directory, I copy all the ZD2, the JSONs, the BMPs to that file. So let's recall that grep there. And here we see we just got microtubes as the name. So that's that. If we do the same thing now in the G1XFour, because people, what's his name? Pi, I quite like that guy. He was explaining you should turn on these cabinet models, and I had a B1XFour originally. What cabinet models? Yeah, when you look through the guitar one, there's plenty of name mic. Yeah. So if we take, any at random we can look at. Let's go further down. Yeah, I mean, basically the mic settings you can now see are in these specific. In fact, if we were to recall that and change it to grep -il, this will give us the list of names, yeah. And so now we can see that the G1XFour has got these mic parameters in these particular cabinets or whatever, and so they're good ones to switch on. But if we just go into this G1XFour because we've got it plugged in, we can now let's have a look at what's in this thing here. So number 50 has got some stuff. Let me just get this out of the way so you can see it, because I didn't realize I'm hiding the screen. It's got a couple of parameters in it. So let's say we want to put a vibrato on. So let's get the JSON out. So now we can see from this that it's 11260. So here we can say fx id parameter 123. Let's put the third one on because you can see that there's two already. And so we'll give it 1126. And now something should turn up there, and it does, okay? And that one's just about says vibrato. Sorry for the bad camera. Vibrato, yep. So I can now go into that effect. There we are. And what I can tell from this is it's got a depth which is a maximum of 100 MIDI, currently 40. I can see there's a rate maximum of 78, currently 30. A tone maximum 10, current 7. Or this is really the default actually rather than the current, but you get the idea. So let's look at the balance. That is indeed at 72. Yep. So if I now come up and say, let's change parameter 3. Check that a second, hang on. Make that a bit smaller. Parameter 3. Okay. No, fx3, parameter 4. Let's give it a value of 20. And indeed, it has gone down to 20. And if we look at one of the other parameters, this is where I need better glasses. And this is why I'm doing this. See, the tone currently says 7. You might just see my head going in there. I can't read that with my glasses in this whatever. But now I can say to it, hey, number 3, we've got the maximum of 10. So let's give it a value of 2. And something changes. Let's give it a value of 10. It should be at the max. And it is, yeah. So this now means that pretty much we're able to interrogate a G1X, G1XFour, B1X, B1XFour, pull out the data of the max. I can get the screen data because that will be different. So some of these values, it will say, I don't know, let's look at this one, 78 as a number, the rate, yeah. So when we look at this is parameter 1, so let's put parameter 1 to 78. That should be at the max, yeah. Oh, sorry, 2, not 1. My bad. There. So, but you see that rate now says some sort of what is it? A quaver times 20. I can sort of read these out of the screens, yeah. So I have somewhere fx star dot shell. I have somewhere the ability to read this dot slash fx m1 m2 values. Oh, hang on. Editor on. Get more data because you want to clean the cache. And this will be turned into programs of GUIs, yeah. And then I want to run fx m1 m2 values. Now, in this particular case, I think I've got single presets, so 3 should be enough. And that should produce some, wait a minute, I have to give it a name. So let's get more data. 3 demo.bin. So I think that's what I need to do. There we are. Right, I think it's that one I should be using. B1X for decode fx values. Let's see if that's the right one I should be using. There. Okay, that was one I should have used, yeah. So this one now comes back and tells me that I've got on off, it's on. Vibrato is currently 78. Depth is X20. So you see, I can see the X20 part, but I haven't got this funny little quaver symbol yet. So that's what I'm printing this stuff out here, because the 30 is a 0, 32 is the 20. So that's the 20 bit, 78 is a times. So 0019 is being used to represent that funny little quaver. And what I need to do is to work out from Unicode standards or UTF, whatever encoding they're using, is there some linear relationship between those first 2 bytes coming out and some sort of offset to turn it into a Unicode. So that's what I'll be doing maybe next weekend when I have more time. And then hopefully I can start to produce the symbols in a mapping. But you see, we've come quite far here, or at least I think we've come quite far. We can now really pretty much control most of this now. And so soon I'll be breaking out the touch screen and using that. It might even be easier to basically use Mundwell's code modified, see if I can get him to help me check in something more sensible to it, because my code not his code, my code to be more sensible, because my code isn't very clean, yeah. But it's okay, it does the job. And so now, as I said, I can use these sort of files to read into something. It gives me some idea of the maxes, the names, the explanations for display, and it might be better just to use some standard Python. There's this tkinter is a tickle tk TCL/TK wrapper, and I used to use that years and years ago. It was quite neat. So that might be able to do all I need. Anyway, that's where I am at the minute. I think we've come quite a long way. We can basically interrogate the pedal from first principles, get the ZD2 file, which gives us the ZDT file, the table, which gets us the ZD2s. From the ZD2s, we can pull out all the information about the name, the group, the ID, the description, the parameters, and the max values in terms of MIDI, and whether it's a pedal or not, on all this stuff. And I guess this is whether it needs to be inverted or not. So we can pull all that information out. There's a little bit of work to do to turn it into the on-screen display, but we have pretty much the capability to do that. And then we can also pull out all of the all of the patches, and I can decode those as Manjwell can too, and I can probably turn that into some sort of JSON that will tell me which FX ID it's using or what have you, and use that to describe the pedal for display. So quite exciting stuff, I think, for me at least. Anyway, thanks for watching, and bye-bye.